Richard Feynman, a famous physicist, once said, and I'm paraphrasing, if we lost all of our scientific information but were able to save one sentence, that sentence should be the atomic hypothesis, meaning matter is made up of atoms. This amazing quote made me realize how important it is to understand matter in terms of atoms. What really matters is matter, and what really matters within matter are atoms and how they bond together. Atoms are very small pieces of matter that combine to make all the stuff we know, like water and sand and Spam. Of course, no one really knows what's in Spam. To really grasp what is going on in the realm of chemistry, we need to think of matter in terms of these particles. Chemistry makes more sense when you can visualize atoms and how they are moving, and they are moving all the time. It's difficult to picture atoms when we can't see them with our eyes. Back to our can of Spam. Since it would take the entire career of a budding PhD student to really determine what is in a can of Spam, let's fill it with water. In one can of Spam, there are approximately 8 times 10 to the 24th molecules of water. Its volume is about a cup. And that is a really big number, which tells us that molecules of water must be really, really small. So to aid in the visualization of the size of the atom, or in this case, a molecule, I want you to imagine that a molecule of water is the size of a grain of sand. We can see the grain of sand if we look closely, and yet it's small enough that we can use it to demonstrate the size relationship of the atom to the matter it makes up. If we assume a grain of sand is approximately a sphere with a radius of 0.025 centimeters, to calculate the volume, we would use 4/3 pi r cubed.
Let's calculate the volume of 1 grain of sand. 4/3 times pi times 0.025 cubed gives us 6.5 times 10 to the negative 5th centimeters cubed.
If one can has 237 centimeters cubed, how many grains of sand are there in one Spam can of sand?
Now let's calculate the number of grains of sand in 1 can of Spam, which is approximately 1 cup. We'll take 237 centimeters cubed over 1 cup times 1 grain of sand having a volume of 6.5 times 10 to the negative 5th centimeters cubed. That gives us 3.6 times 10 to the 6th grains of sand per cup.
How many grains of sand are in 1 gallon of sand?
Now let's calculate the number of grains of sand in 1 gallon. We've got 16 cups per gallon times 3.6 times 10 to the 6th grains of sand in 1 cup. That gives us 5.4 times 10 to the 7th grains of sand per gallon.
How about an Olympic-sized swimming pool? It holds about 6.6 times 10 to the 5th gallons. How many grains of sand will it hold?
Now let's calculate the number of grains of sand in 1 Olympic-sized swimming pool. We have 6.6 times 10 to the 5th gallons in 1 Olympic pool times 5.4 times 10 to the 7th grains of sand in 1 gallon of sand. That gives us 3.6 times 10 to the 13th grains of sand.
Okay, we still don't have as many grains of sand in a pool full as we do molecules of water in 1 Spam can. So let's think really big. How about the number of grains of sand in the volume of the Gulf of Mexico? The Gulf of Mexico has a volume of about 6.4 times 10 to the 17th gallons.
Let's calculate the number of grains of sand now to fill the Gulf of Mexico. We have 6.4 times 10 to the 17th gallons in the Gulf times 5.4 times 10 to the 7th grains of sand per gallon. That gives us 3.5 times 10 to the 25th grains of sand in the Gulf.
Let's try to go back a little bit. How many cans of Spam is that in water molecules? We'll change our grains of sand into water molecules and calculate back.
How many cans of Spam is that in water molecules? Well, we've got 3.5 times 10 to the 25th molecules of water. We're going to multiply that by the molar mass of water, 18 grams, and divide it by the number of molecules in a mole, which is 6.02 times 10 to the 23rd molecules. And because the density of water is 1 gram per milliliter, approximately, we're going to use that to change our grams into milliliters. And then we're going to change our milliliters into cups, using 1 cup has 237 milliliters. And all this calculates out to be 4.4 cups or cans of Spam filled with water.
So the number of grains of sand in the volume of the Gulf of Mexico turned into water molecules only fills about 4.5 Spam cans. That's not Spam-a-lot, but it's still more cans of Spam than I'd want to eat. So you may ask, why is this important to know? To understand chemistry, you must think in terms of particles.